I'm going to be going over matrices, and that is just adding and subtracting matrices. So let's get started. So like I said, this video is going to be over adding and subtracting matrices, and to first start out, we should probably go over what a matrix is. And a matrix is a rectangular array of numbers in rows or columns. So I'm going over unit 4.1, adding and subtracting. So we're going to go over some vocabulary first. And the first vocab word, I guess, is corresponding elements. And these are elements in the same position in each matrix. Equal matrices. Equal matrices have the same dimensions and equal corresponding elements. Next, we have matrix equation. And this is an equation in which the variable is a matrix. And a zero matrix is 0, or 0mn, is the mn matrix whose elements are all zeros. Next we have analyze, and this is just to closely examine objects, ideas, or relationships to learn more about their nature. Next we have a key concept, and this is matrix addition and subtraction. Very important. So some essential understanding is that you can extend addition and subtraction. To add matrices A and B with the same dimensions, add corresponding elements. And to subtract matrices A and B with the same dimensions, subtract the corresponding elements. So here we have our equations that we will keep referring to as the video goes on. So we have our A and B equations, and like as it says on the side, to add matrices A and B, you're just going to add these terms. Like we have the 1, 1 together adding, and we have the 1, 2 AB together adding, and A, 2, 1 and B, 2, 1 adding. So you get what I mean when I say corresponding elements, I guess. And then to subtract, it's the same thing, except you're subtracting, obviously. So next we have some properties of matrix addition, and we'll just start with if A and B and C are M times n matrices, then here are examples. A plus B is an mxn matrix, and the property that corresponds with that is the closure property of addition. Next up we have A plus B equals B plus A, and the corresponding property is the commutative property of addition. Next we have A plus B plus C equals A plus BC. This is the associative property of addition. There is a unique mxn matrix O, such as O plus A equals A plus O equals A. This is the additive identity property. Next we have for each A, there is a unique opposite negative A, such that A plus negative A equals 0. And for these, when I said O, I meant 0. Sorry about that. But this is the additive inverse property. So here is our first example for adding matrices, and it is matrices of 3, 1, 0, negative 2, plus 4, 0, 3, negative 1. So the corresponding step would be to start with the equation in the original AB form, as I showed you in a few slides back. So it is already in that form like this. This is the AB form that I'm talking about, in case you don't remember. So next, we will set it up into A plus B form, and that's just merging the corresponding elements. So the first term here, adding it to the first term here. So 3 plus 4 is set up like this, so hopefully that makes sense. And then the second term, 1, will be added to the second term, 0 of the B equation. So again, 0 plus 3, and negative 2 plus negative 1. Yeah, sorry, I just thought I got that wrong. No, I didn't. Anyways, so once you set it up like that, then you have your answer after you do the addition. So we know that the answer is 7, 1, 3, and negative 3. So we have that. And actually, I think I typed this wrong. Did I? I did. This is actually supposed to be in -2. So -2 plus minus 1 is -3. Okay, I just put in the wrong number. It is still the same answer. I got that correct. Okay. So after that, do the addition and plug it into the original equation to check for accuracy, which I did not do when I was making this PowerPoint, so sorry about that. Next up, we have our first problem. After seeing the example, we should be able to do this together with no problem. So first, we're going to start with the equation in the original AB form, and here it is. So we have a matrix C of 0, -1, -2, 0, 3, and -2, plus 1, -1, 3, -1, 2, 0. As you can see, it's already in our AB form. So next we're going to put it into A plus B form, which I've done here like this. So it would be 0 plus 1, -1 plus -1, -2 plus 3, 0 plus a -1, 3 plus 2, and -2 plus 0. And our answer, once we do all the math, is 1, -2, 1, -1, and 5, -2. So next, we'll plug in our answers back into the original AB equation to check for accuracy. And we know we have our answer, and we've done it correctly. So here we have our example 2 for subtracting matrices. So we're now going to do a subtracting one after we've done a few addition ones. So we're first going to start it with our original AB form, just like we did for addition, same exact thing. So for this, we have matrix C of 1, 2, -2, 3, 0, -1, minus 4, 2, 2, 0, 4, 3. So I already have it in our original AB form. Next, we're going to put it into A minus B form, as opposed to A plus B, since we are subtracting. So, of course, we have 1 minus 4, 2 minus 2, -2 minus 2, 3 minus 0, 0 minus 4, and -1 minus 3. So we have it in our A minus B form. So next we can do the subtraction to get our answer. So of course it would be 1 minus 3 is -3, 2 minus 2, of course they cancel out, so it's 0, -2 minus 2 is -4, and 3 minus 0 is obviously 3, 0 minus 4 is -4, -1 minus 3 is -4. So once we have our answer, of course, we can plug it back into the original equation to make sure we have our correct answer, which we have done it correctly. So now we'll do a problem, which will be a little bit tougher than the example for subtracting. So we're going to start with 1, 2, 0, 4, -1, -1, minus matrix C of -1, -1, 4, 1, 3, 1. So we'll start with the equation again, AB form. Next we will plug it into A minus B form, which will give us 1 plus 1, 2 plus 1, 0 minus 4, 4 minus 1, -1 minus 3, -1 minus 1. So following that, we will do subtraction to get our answer, and the answer is 2, 3, -4, 3, -4, and -2. So of course we'll plug it back into our original form, and we know that our answer is correct, so we did all of our steps correctly. So next we have a few examples, or just practice problems, I mean. So we have a matrix C of 6, 7, 4, 3, 2, 8, 2 minus 4, 1, 9, -3, -2. So then, of course, we know our steps, even though they're not here. We're going to plug it into A plus B form, which is 6 plus 2, 7 plus a -4, 4 plus 1, 3 plus 9, 2 plus a -3, 3 plus a -2. So our answers for this would be 8, 3, 5, 12, -1, and 1. So those are our answers, and we know that is correct because we did all the math ourselves. We followed our steps, so we know we did it right. Next, we have the matrices of 2, 5, -4, and 3. We also have a matrices of 2, -2, or -5. So of course we're going to plug it into our A minus B form, which is 2 plus 2, 5 plus a -2, -4 plus 4, 3 plus a -5. So then our answer would be 4, 3, 0, and -2. So that's what I just said, so we know we did it right, because of course we followed our steps once again. So our last adding matrices practice problem is matrices of 4, 7, 6, -2, 3, 7, plus the matrices of 2, 9, -11, 3, -6, and 4. So of course we're going to put it into A plus B form again. So literally the same steps. It kind of gets a little redundant, but I think these are pretty fun to do. So anyways, 4 plus 2 will be 6, then 7 plus 9, 16, 6 minus 11 will be -5, yes, -5. And then -2 plus 3 will be 1, 3 plus a -6 is -3, and 7 plus 4 is 11. So, yes, just as I thought. Okay. Now we're going to go on to some practice problems for subtracting matrices. So our first subtracting matrices problem is the matrices of 4, 5, 6, 2, 4, 6, 2, 3, 4. Oh, sorry, I completely read that wrong. Oh my god. Anyways, I meant the matrices of 4, 5, 6, 2, 3, 4, minus the matrices of 2, 4, 6, 1, 2, 3. So of course we're going to put it into A minus B form because we are subtracting, which is 4 minus 2, 5 minus 4, 6 minus 6, 2 minus 1, 3 minus 2, and 4 minus 3. So this will be 2, 1, 0, 1, 1, 1. And there you have it. That's our answer. Next, we have the matrices 1, minus 2, minus 3, 4. And we also have 6, minus 2, 3, and 7. So we put it into A minus B form, which is 1 minus 6, -2 minus a -2, -3 minus 3, and 4 minus 7. And our answer is -5. And then this negative and a negative turns into a positive, so 0. And then this will be -6. And then this would be -3. Yes, so that's our answer. And by the way, I don't have the answers like in front of me. I'm doing this off the top of my head. So anyways, the last subtracting matrices problem we have is the matrices of 2, 8, 0, 9, subtracting the matrices of 5, 6, 11, and 3. So we have 2 minus 5, 8 minus 6, 0 minus 11, and 9 minus 3. So 2 minus 5 would be -3, 8 minus 6 would be a 2, and 0 minus 11 is still -11, and 9 minus 3 is 6. So there you have it. Those are our practice matrices problems. Now let me just check the time we have here, because if I'm not to 10 minutes yet, I do have a few more